So, good morning and welcome to welcome to all my students and learners for today's class. Actually, some of my students replied that rather than going to all theoretical and technical discussion to show some practical example or this from my experience how this is done. So it is, I think, long back in the year of 2017, I think. So I went to Northeast for actually one of my directors, a very close friend. He is working. He's a, I think, station head that time there. So they are in the Kaplan. And they're experiencing some abnormal noise. So this actually initial signature for aerodynamics that I will discuss in my subsequent lectures. That is one. It's called eye diagram. So very high precision with high sensitivity. Some ultrasound sensors are placed across the circumference of the rotating shaft and the signature how it is, because in case of as I told, in case of hydrodynamic or hydrostatic bearing, the shaft will be floating, so it will uh, based on the um, uh, oil film formation and the pressure, the upward lift, this center of the journal, it will be not always in stable. Practically it will be not in coinciding with the center of gravity of the entire system. Okay, so it will be as it is floating, some external excitation always it will be working, so it will be like that, it will be rotating, the center it will be moving, the locus of the center it will be different, sometime very near to circle or ellipse or tilted ellipse, something like that. So this signature, with this signature you can understand that what is the situation, what is the dynamic condition of the um, rotor dynamics. Okay, maybe due to some residual mass, there will be some in case of residual mass, what type of eye diagram it will come. In case of, say, there is some looseness, what type of eye diagram you can, from the eye diagram how you can predict it. That all these things I will discuss in my subsequent lectures, but today, as my some of my student told, so I am sharing one problem. This is long back. So there is some abnormal noise they're experiencing from the bearing casing. Okay. So normally what will happen, people will remove that and will check whether is there any some problem is there or not, and then they will do something, and after that again they will assemble it and again test. So this will take a lot of times. So to avoid the time, okay, so people will, after doing this kind of things, any maintenance, they will, with the new parameter, they will try to check the condition of the bearing, and if it is satisfactory, then only they will finally assemble the system. So normally in case of journal bearing maintenance, one term is very common which is called scrapping. Okay, so this is nothing but it's a very uh, like that, you can tell it's a very precision process of the removal of the surface material. If surface become due to some reason, rubbing or wear and tear, so the surface become uneven. So very precision way they have to remove the unfinished surface material, uh, which will ensure the proper geometrical alignment. Okay, proper geometrical alignment, uh, and it is the surface finish is evenly spreading the over the from the it is from the point of the bearing contact with the journal, it is evenly spreaded over the entire circumference. Okay, the inner lining of the bearing. After doing this, people normally if it is a very small system, they will put and they will again check the same sound is coming or not. In case of our vehicle also, there is a uh, you can see there will be a in our car, in the car wheel, there will be things called caliper, wheel caliper, brake caliper, so that sometimes some noise or your tire, it will be means that it will be getting heated, the disc area. So that time this kind of maintenance they will do the smoothening, do some surface finish, and again they will put the disc and brake shoe, and like that. It's a small system, but in case of very big system, it is a time consuming. It will take a lot of time. So after these things, they will check the using some simulation method. They will ensure that whatever they did, it is okay. Then only they will go for the final assembling. So just I will show you the video I found from my hard disk. So this is the thing. You see, this is this is a one half of the bearing. So they found that there will be some wear and tear. So they are, you see, very, it's a very precision process, as I told. So they are removing some portion of the bearing material, which was creating the unevenness in the bearing. Hmm. And after that, uh, this only small these things only I have. It's a very lengthy process and very precision process. Good skill required. Okay. So this they have done, and after that, that RA tester. I think people who are uh, uh, in NDT field, they are very familiar with that RA tester, that roughness average. It will calculate, and they checked the things, and then this data they given to me to do the simulation and check the behavior. Anyway, that this is a long back, and this data right now I can't remember, but and it is not advisable also to share some proprietary somebody's proprietary design data. So I will show you some generic example that after these things, what people will do, and to ensure that their scrapping will give some better and satisfactory results. So here I will show very it's a very basic analysis problem. You have to do the transient also, but as you know, the transient will take more time. So I will show you the steady state. uh, Here you go to fluid flow, then thin film flow, and you select this, add this, and in steady you go for the steady state analysis. Okay, Just I'll show you how to do that. So I'll define some parameter. So let us the radius of the journal. So let us take it is 200 mm, 200 mm. Then let us define the height of the journal, means width of the journal. So that is, say it is 400 mm. So it is 400 mm. Then the clearance after removal of that uneven surface from the bearing, using the after confirming the surface roughness, the clearance between the this journal and the bearing is measured. Uh, Say that is 0.003 mm. Hmm. You can take, it's a generic thing, and the RPM is, you can take say 1000, just for example, 1000 RPM. So convert into radian per second means it is pi n by 30 pi. So pi by 30 you have to multiply, and this will be your radian per second. Hmm. And another parameter is very important, that you can tell, eccentricity. Eccentricity means the when it will be moving, what kind of, as I told, it will form a locus. So that eccentricity also, it is in a circle, eccentricity is 1, you can understand. The major and minor axis will be same. In case of hyperbola, it is 1. So it will, this is a non-dimensional parameter which uh, will be between 0 to 1. So for this you can take something like zero point 0.6 or something like that, you can take. Okay, then I'll define the variables. So here first the angle. So you know, angle will be always, for any point the angle will be tan inverse y by x. So a tan 2 uh, y by x. Okay, this is the syntax, nothing else, and this will be in radian. Now the oil thickness. So oil thickness, it will be the formula, the standard formula. This I will come all in my subsequent lectures. So this will be uh, the clearance into 1 plus eccentricity of the locus into cos theta. Okay. Now coming to the how the this journal velocity, it will move further, whether it is after doing this treatment, whether it is heating the collar pad or not, and then again it will be problem. So this also you have to check. So that I am uh, defining one variable ux, which is nothing but minus, what variable I have choose there, omega w. So ux, I am defining it as minus omega into r into sine component, correct, based on the geometry. You can see here, this is x, z and y. So x will be this side, so it will be minus. So minus, and your uh, vy, that is the y direction, y is positive only. So omega into r into my cos theta. Very simple. Let me check it is recording or not. Yes, it is recording. So now I am coming to the geometry. It says cylinder, so I want not as a solid, it will be surface. So radius is already my r, and it is my I defined already. It's so build. So this is my bearing portion, or sorry, this is the oil film. Now go to this, and here nothing to do. This so this will be my nothing but the thickness, and my this velocity, it will be user defined, so it will be my ux, and this will be my vy, I think. Okay, then what are the parameters I have to, yes, from it is user defined, so let us take some arbitrary value. Viscosity, let us take 0.01. Okay. Mm, and this is okay, let it be like this. So I'll enable the it is already enabled advanced physics option. Now go to the mesh, let it be physics control mesh, and final, and this one let us compute and see. Now you see the pressure, you can see the pressure profile. Okay, so this how it will be lifted, where it will be, as it is very thin. So if you zoom it, the portion, oh, it is very this one. So if you with this, you can see now after modification this problem, whether if you do the transient analysis, you can see, you see here this area only that lifting will be taking place, and all the things, if you do the transient analysis, you can conclude it. So this was requested by my student Vikash, I think, from the um, video whatever I have shown, and how these things, this concepts are utilized. So hope you have understood. So anyway, this whatever I know, even though I am not an expert in this, but whatever from my past experience and what I know, I will try to give you the glimpse of that, and hope definitely that will be helpful in your professional life, uh, remaining professional life. Thank you so much. Thanks for your patience.